Good morning, students. Am I audible?
Yes, sir.
So we'll get started. So last class we were discussing the basics of ray optics, right? So we started off with ray optics and we saw one of the derivations that gives you the relation between the focal length and the radius of curvature. Am I right? So I hope this is a topic we have seen. So there are some important terms that I would like to mention here. So there are two things I told you in the previous class. What are the assumptions we are taking into consideration? Do you guys remember what are the assumptions we are taking into consideration? One is mirrors are one of the assumptions I told you is mirrors are very small. That is, their aperture is very small. That is one of the things. And what is the second thing I told you? The angles that we are dealing with will be very small, right? So apart from that, I want to introduce two more terms which are called as marginal rays and paraxial rays. So these are the two other important terms that you need to know. So as the name suggests, marginal rays are those rays which are far away from the principal axis. Okay, which are the rays which are away from the principal axis are generally termed as marginal rays. See, for example, if I take a concave mirror, so this is going to be the principal axis. If I take a ray parallel to the principal axis, if they are away from this principal axis, we call them as marginal rays. If the rays are closer to the principal axis, we call them as paraxial rays. Okay. So generally, when you talk about paraxial rays, these rays make very small angles with the mirror. since they are almost parallel to the principal axis. I told you, right, all the angles are considered to be small. So what will happen is, when you consider the mirror to be very small, then principal axis itself will be closer to the ends of the mirror. As a result of which, what will happen is, the rays which you consider parallel to the principal axis by default will become paraxial rays. Okay. So I hope you made a note of this point. So in this chapter, discussions related to spherical mirrors will be restricted to paraxial rays and mirrors of small aperture. Right? And one more point I wanted to mention here is, did you guys make a note of this derivation which I did last class? Relation between focal length and radius of curvature. So you would have made a note of all these things, right? One thing that I intentionally didn't do in the previous classes, sign convention. Okay. So what I mean by sign convention, you guys know what is sign convention, right? Can someone tell me? So if I take a concave mirror, like this, see, the diagram will be big because I cannot draw smaller diagrams and show you paraxial rays. Okay, though the diagram is big, you have to imagine that A and B are very small. Means I've drawn this portion and it is like you are zooming and seeing. When you zoom, it is looking big, right? So this diagram, whatever I've drawn here, is the zoom version of it. So this is the principal axis, right? Now, if I take this as the point P, generally the point P is considered as origin. And any distances measured on the left of pole is considered to be what? Positive or negative? Any distance measured on the left of the pole is considered to be
negative, sir.
Yes, correct. It is considered to be negative. So any distance measured on the right of pole is considered to be positive. Okay. Any distance taken in the upward direction is considered to be positive. Any distance considered in the downward direction is considered to be negative. Okay, so this is the basic sign convention. I hope you guys already know. Like, you take the pole as the origin and take principal axis as the x-axis and draw a tangent to the mirror at the pole, then that will become the y-axis. So with respect to all the distances, if the distances are taken on the left-hand side, they're negative, right-hand side positive, upward direction positive, downward direction is negative. So this is the basic sign convention. I hope it is clear till this step, right? Right. So what I meant by I didn't take the sign convention here is, I wrote focal length here, right? So make a small change in it. So tan theta is equal to, I wrote PA divided by R. No? Here, R is positive or negative. With respect to which mirror did we derive? Concave.
Concave mirror.
So with respect to a concave, R is positive or negative?
R is negative.
R is negative. What about focal length? That is also negative. So what will happen is, here actually you are supposed to put a minus sign. And then they'll get cancelled, where you get R is equal to F. So you can ask me, sir, why are we doing that? They are going to get cancelled. But that is the main rule that we need to follow in this chapter. Okay. So I wanted to tell at this point because we were doing this derivation in a hurry. So the important point to be noted in this chapter is very, very important note. Please write it down. The note that you're supposed to make here is sign convention should be followed during two steps. One is derivation, and the second is solving problems. Okay, both the times you are supposed to do it. While you are doing it 2 steps, you will understand it later. In your 10th grade, you would have learned, they would have given you the formula, they would ask you to solve the problem. So, in solving the problem, you would have actually applied the sign convention concept. But you need to remember one important fact. The formula that is derived itself is derived by using sign convention. Why it is so? You will understand it. Don't worry about it. Okay, but make a note of this. Okay. Next is a relation between F and R for convex mirror. Okay. So this part I am leaving it to you. I am giving it as homework. You guys try and bring it to me. Now I'm going to go to the next part, that is the ray diagrams. Okay. So next part that we are going to see now is how to draw the ray diagrams. So this is also known fact, but yes, we will try to recollect it. So what does this ray diagram? So how do these ray diagrams help us? Where exactly are they helpful to us?
To visualize what we are seeing.
Yeah, it is mainly used to locate the position of image with respect to the object's position. Am I right? So if you know where the object is placed on the principal axis, then it is helpful for you to derive the location or trace the location of the image. So again, we'll be considering small objects and mirrors of small aperture so that all the rays are paraxial. Still, you will stick only to paraxial rays. Okay. So to construct the image of an extended object, see there are 2 kinds of objects that we can always speak about. One is a point object and second is an extended object. So if you want to construct the image of an extended object, the image of the 2 point ends is only drawn. We will not draw it for the in-between points. That is, we will take the ray from the topmost point and from the bottommost point. Intermediate points are not considered for the ray diagram. Okay. Next. The image of a point object lying on the principal axis. Okay. With respect to a point object, what we can say is, if you take the point object anywhere on the principal axis, you are finally going to get the image on the principal axis itself. That is one more important point. So we can draw ray diagrams with respect to a point object also, but in your syllabus, we don't have it. So I'm not going to get into the details of how to locate the position of a point object. We are going to discuss only about the extended object. Shall we get started?
Yes, sir.
There are 4 important steps to be followed while drawing the ray diagram. Can someone tell me what they are? There are 4 important steps that you are going to follow while drawing the ray diagrams. What are they? So first one, if you consider a ray through the center of curvature, then what will happen? The ray is reflected back along the center of curvature itself. You guys know this fact. But what is the reason for it? If you take a ray,
Incidence is 90 degrees, sir.
So when you take a ray like this, can you repeat the?
Angle of incidence is 90 degrees.
Is it 90?
0 degrees, sir.
Yes. Because when it is hitting the mirror, what is the first step that you are supposed to do to draw a ray diagram? You should always draw a normal. So when the ray is hitting the mirror, you should always draw a normal. at the point of incidence. When you draw a normal, what would be the value of theta? Theta is equal to 0 degrees, right? So the angle of incidence is 0 and angle of reflection will also be 0. That is the reason why a ray passing through the center of curvature will retrace its path. Okay, this is with respect to the concave mirror. The same is the case with respect to convex also. Here I've drawn a wrong diagram that is very complete. Okay. Second, if you take a ray parallel to the principal axis, what will happen? A ray considered parallel to the principal axis after reflection will pass through a point on the principal axis. What is that called as?
Focus.
It's called as the principal focus. This is also known with respect to concave mirror. You will have a real focus. With respect to a convex mirror, it will appear as if it is diverging from that point. So you will have a virtual focus. So it is something like this. A ray considered parallel to the principal axis after reflection will pass through the focus. So this is with respect to concave mirror, whereas with respect to convex mirror, it will appear as if it is diverging from this focus. Third, a ray passing through the principal focus or ray appearing to converge at F is reflected parallel to the principal axis. So ray passing through the principal focus after hitting the surface will get reflected back parallel to the principal axis. Whereas here it will be something like this. Okay. Fourth one. A ray striking at pole is reflected symmetrically back in opposite direction. So when a ray is hitting the pole, then what will happen? At the pole, how will you draw the normal? So at the pole, if you draw the normal, which line will act as a normal? The principal axis itself, right? And this ray will get reflected symmetric. Means if the angle of incidence here is I, the angle of reflection will be R. So same thing happened here. Okay. So all these points clear?
Yes, sir.
Right. So based on this, you know where all you can locate the positions of image. So there are 6 ray diagrams with respect to concave mirror and 2 ray diagrams with respect to convex mirror, right? So based on this, what we will be doing is we will be seeing the mirror equation or called as the mirror formula. So write down the heading. So before I start, what are the important steps I told you? In this chapter, the rays considered are paraxial, the mirrors are small, and what is the third important point I told you about sign convention? Sign convention should be applied while the process of derivation as well as the process of solving a problem. So these are the 2 important points you need to have in your mind. So for mirror formula, we are going to do the same thing. Okay. Let me say this is the principal focus. This is the center of curvature. See, the diagrams are not to the exact measure, so there might be some imperfections in the diagram. Okay. So if I take an extended ray, extended object AB, then if I consider a ray parallel to the principal axis, it will go and hit the surface. After hitting the surface, how will it get reflected? It will pass through the principal focus. Right. Next. if you consider a ray hitting the pole, it will get reflected back symmetrically. So there are two rays that are more than sufficient for you to locate the position of image. You can actually draw the other rays also if you want. If you take a ray through the center of curvature, I told you, right, it will be slightly imperfect. Now what we can do, okay, so this is how a ray diagram can look like. Or the fourth ray you can take through the focus and become parallel to principal axis. All the rays will be meeting at this point. And this is the position where the image is formed, A dash and B dash. Okay. So if I take this point as P, now tell me the names of all the distances. What is the distance from the pole to A called as? What is the distance from the pole to the point A called as? It is called as the object distance. The distance from the pole to the center of curvature is called as the radius of curvature. The distance from the pole to the point A dash is called as the image distance. The distance from the pole to the focus is called as the focal length. All these distances with respect to this mirror are U, V, R, and F are negative. Correct? They are negative. Right?
Yes, sir.
So what is the name of this chapter? I told you ray optics or geometric optics. Right? So we will be taking the help of geometry to derive all the relations. So what are the relations that we are trying to see? Mirror formula, mirror equation, or sometimes it is also called as Gauss formula. This is the Gauss formula for mirrors. Don't get confused between Gauss law. Okay, this is very rarely referred to it as Gauss formula. Just for your information, I'm telling. If you feel that it will confuse you, forget about it. Okay, it's called mirror formula or mirror equation or Gauss formula. So what does this formula tell us? You guys know this formula. What is it? 1 by V plus 1 by U is equal to 1 by U. So tell me one thing, 1 by V plus 1 by U is equal to 1 by F is applicable for what kind of mirrors? It is applicable to spherical mirrors of any type. So whether you talk about a concave mirror or a convex mirror, it is still applicable. Okay. Now,
So I have a doubt, sir.
please tell me.
And the formula, should we add a negative, or when you're substituting the values, we should add a negative? It's,
You're saying 1 by minus V plus 1 by minus U
yes,
equal to
sir.
1. No, it will not be like that. I told you, right, you will understand the importance of sign convention. I'll tell you a story. So in this case, in the derivation process, you will get like however you asked. You will get 1 by minus V plus 1 by minus U is equal to 1 by F. In some cases, what will happen, you will get 1 by V plus 1 by minus U is equal to minus 1 by F, something like that. Things will change, but ultimately, when you apply the sign convention process and do right, you will still get the same answer.
Okay,
I'll tell you. You will slowly understand. So if you take, okay, to answer your question in a brief way, if I ask you, is this the only ray diagram possible for a concave mirror? The answer is yes or no. Is this the only ray diagram possible?
no,
Where did
sir.
I take? Yeah, where did I take the position of the object? I took it beyond the center of curvature. It is my wish, right? I can take it between the center of curvature and focus also. Correct?
Yes, sir.
So when I do that, what will be the changes? The focal length and the radius of curvature will still be the same because they are fixed quantities with respect to a specific mirror. But if I take the object to be between the center of curvature and focus, the image will be formed where? Can you guess? So always with respect to ray optics, no, there is something called as symmetry and reversibility. So when I took the object beyond the center of curvature, where is the image formed?
Between C and F.
Between C. So if I take the object between C and F, what do you think will happen? The image will be formed
beyond C.
correct. Right? It will be formed beyond C. So when it is going to form beyond C, can I say that there will be a change in the value of U and V? In this case, can I see V is less than U, accepted? Whereas in the other case that I'm saying, U will be less than V. Okay. Yeah. So have this in your mind. As of now, I'm not going to do both simultaneously and confuse you. First, we will do this. Have this point of U less than V. We will have a discussion about it at the end of this derivation. After we complete this derivation, we'll have a discussion.
Okay.
Okay. Now, I told you already, it is called as geometric optics. Correct? So we need to take the help of geometry. So what I'm going to do is, I'm going to look for some right angle triangles. Okay, I'm going to look for some right angle triangles and create a similarity between them. So if I take the right angle triangle A, B, C and this thing, this is A dash, B dash, C. So if I take the triangle BAC and B dash, A dash, C, what is that I can say? If I take this angle as alpha, this angle will also be alpha. And this is 90, this is 90. So according to AA criteria, can I say that BAC is similar to B dash, A dash, C? According to which criteria? According to the AA criteria, angle criteria. Right? If that is the case, I will be taking only those distances which are meaningful to me. Okay. So the distances which are meaningful to us are AB, because it is going to give you the height of the object, and A dash, B dash is going to give you the height of the image. Similarly, if I take AC, AC is such a distance which will give me the relation between all the distances lying on the principal axis. Correct? So if I say, tell me one thing. Yeah. BAC is similar to triangle B dash, A dash, C. So can I write BA divided by B dash, A dash is equal to BC. BC is of no use because BC is this length. So I'll not take BC. Can I write this to be equal to AC divided by A dash? So what is BA? H naught. B dash, A dash is HI is equal to, what is AC, guys?
U minus R, sir.
That's right. So AC is U minus R, but with a negative sign. Correct. U and R both are negative. So U minus R is the distance. But since U minus R is also on the left-hand side of the pole, can I write it with the minus sign? The whole divided by, what is A dash C? A dash C is CP minus A dash P.
Sir, could you repeat?
A dash C, A dash theta A dash C is nothing. So this distance is nothing but CP minus A dash B.
Yes, sir.
So how much is CP?
U
CP is U. CP is the distance
R
between
minus
both.
V, sir.
Minus
Yes,
of.
minus of R minus 1. Minus of R minus 1. See, fortunately here minus signs are getting cancelled. Okay. So H naught divided by Hi is equal to U minus R divided by R minus V. We have taken the sign convention. So first. Now the second set of right angle triangles that I'm going to look at is BAP and B dash A dash P. So if I take the triangle BAP, how much is this distance? The distance between P and A is U, and this is H naught. Guys, I forgot one important point here. What is it I forgot? I took the sign conventions on right hand side. Left hand side, observe. H naught, is it positive or negative?
It's positive, sir.
What about HI?
Negative, sir.
Negative. I forgot to write that. So it should actually be having a minus. Okay. Similarly, H naught, this is U. I can take the triangle B dash A dash P also. So if I take the triangle B dash A dash P, then this distance is going to give me B, and B dash A dash is going to give us HI. So can I say triangle BAP is also similar to triangle B dash A dash P? The reason is very simple again. Angle A is 90 degrees in both the cases. If this angle is theta, this angle is also theta according to the laws of reflection. So according to the same AA criteria, these two are again similar. So can I write BA divided by B dash A dash is equal to AP divided by A dash B. So BA is what? H naught divided by B dash A dash is minus HI is equal to, what is AP, guys? AP is minus U, A dash B is minus V. So let me take it as 2. So don't be in a hurry to cancel this minus sign. If you observe 1 and 2, left hand side is minus H naught by HI. So can I say from 1 and 2, U minus R divided by R minus V is equal to minus U by minus V, minus minus getting cancelled. So if I rearrange this equation, UV minus VR is equal to UR minus UV. So minus UV will come this side, VR will go to the other side. So 2 times UV is equal to UR plus VR. Okay. Divide with UVR on both sides. When you do that, what will you get? 2UV divided by UVR is equal to UR plus VR divided by UVR divided by UVR. UV will get cancelled. UR will get cancelled. VR will get cancelled. So 2 divided by capital R is equal to 1 divided by V plus 1 divided by U. So what is 1 by R, guys? Sorry, what is 2 by R? We know that R is equal to 2F. R by 2 is F. 2 by R will be 1 by F. So 1 by F is equal to 1 by V plus 1 by V. Now, did you understand how this relation has actually come? So if you don't apply sign convention, maybe you would have got some other answer.
Sir, could you pause for a minute?
Sure, 1 minute. Is this enough?
Yes, sir.
Right.
Done, sir.
Sir? So, just for the sake of understanding, I'm going to do another derivation very, very fast. Okay. I'm not going to prove any similarities or something. You can visualize it. So if I take an object between the center of curvature and focus, then if I take a ray parallel to the principal axis, after reflection will pass through the focus like this. Okay. The ray is hitting the pole, it will get reflected back like this. And what can I say about the ray through the center of curvature? So ray through the center of curvature will travel without any deviation. If I take this as AB, this as A dash B dash, can I say that triangle BAC is similar to triangle B dash A dash C? So BA divided by B dash A dash is equal to AC divided by A dash C. Okay. So what is BA? H naught divided by minus HI is equal to, what is AC? So this distance is V, this is U, this is F, this is
R minus U, sir.
Minus of R minus U, the whole divided by A dash C is minus of
B minus R.
B minus. Let this be equation number 1. Tell me the next set of triangles which are similar. Triangle
ABP
BAP is similar to
and B
triangle.
dash A dash B.
So BA divided by B dash A dash is equal to AP divided by A dash B. So H naught divided by HI with the minus sign is equal to, what is AP?
V, sir. I mean U. R.
Yeah.
U, sir.
Yeah, minus U divided by A dash B is minus
V,
U.
sir.
So cancel them. So what will happen here? 1 is equal to 2. So here also minus will get cancelled. R minus U divided by V minus R is equal to U divided by V. So rearrange it. VR minus UV is equal to UV minus UR. Just to go this side, go to the other side. VR plus UR is equal to 2 times UV divided with UVR on both the sides. 1 by U plus 1 by E, V will be equal to 1. Is it clear?
So we use the same step but for a different ray diagram, right, sir?
Sorry?
So we use the same steps as the derivation except
Yeah, use the
for a
same
different
steps.
ray diagram.
Yeah. So what can you try is, for you to understand it better, you can take a concave mirror and try. So when you take a concave mirror, when you take any ray beyond the focus, it will hit the mirror. Sorry, focus is not on this side. So when you take the ray anywhere, what will happen? So ray will hit the surface and it will get reflected back. So this is the focus, and when it hits the pole and reflects back like this, this is where the image is formed, which would be A dash, B dash. Okay, so this will be AB and this will be A dash, B dash. Okay. So this distance will be U, this distance will be V, this distance will be F, and this distance will be R, where this point is center of curvature. Now you try and see, right? You take, now tell me the set of similar triangles.
Triangle ABB and BA dash B dash.
Okay. Next. So if I take a ray from the top surface as if it is going to hit the center of curvature, can I say that this is going to retrace the path also? So if I take a ray like this, then can I say it will retrace this path also? But still the image is formed at this point. So can I take the triangle BAC similar to triangle B dash A dash C? Are you guys able to understand what I'm trying to say?
Yes, sir.
Right. So what will you get? BA divided by B dash A dash is equal to AP divided by A dash B. Similarly, BA divided by B dash A dash is equal to AC divided by A dash C. So what is BA? H naught. B dash A dash is HI is equal to what is AP?
U.
Let's not take the sign convention and see what we are going to get. U divided by A dash B is
V, sir.
V.
V. I'm not taking the sign convention. U divided by V. Similarly, H naught divided by HI is equal to what is AC? AC is U. Yes. Or U plus R divided by A dash C is R minus V. Okay. So U by V should be equal to U plus V divided by R minus V, which implies UR minus UV is equal to VU plus VR. What will you get? But unfortunately, you are getting the same thing without sign convention also. I understood the reason why, you will have a minus sign here and here. One minus sign. They will get cancelled, so you're getting the answer. You're able to understand what I'm trying to say. So, we unfortunately took all the three scenarios where the sign convention, without sign convention also work. But one thing that we have to remember is, there are how many ray diagrams that are there? So for concave mirror, how many ray diagrams are there?
5, sir.
Not 5. 6. So what are the 6? One is at infinity. So at infinity means when the object is kept at infinity. Second,
Beyond
is kept beyond C. Third,
at C.
at C. Fourth,
Between C and F.
fifth,
At F.
sixth.
Between F and P.
Okay. And for convex mirror, you will have
2 minutes.
Okay. So there are total of 8 ray diagrams that are there. Okay. So without sign convention, if you actually start deriving, right, you're supposed to get 8 different equations, which gives you the relation between B and U. But we saw three, right? All the three work with and without sign convention. But if you can try and see, maybe I'll give you another point. If you can take this point between F and P and try and see, you will not get the same answer. Okay. You will not get the same relation 1 by V plus 1 by U is equal to 1 by F. Rather, you will get some other relation without sign convention. But when you apply sign convention, you will get 1 by V plus 1 by U is equal to 1 by F. Now you would have understood why the sign convention is needed, because if you don't apply sign convention, there will be different formulae that will get arise for different ray diagrams or different scenarios. And it will get difficult for you to remember all these formulae. So to make it as a general formula, they called it as mirror formula. Okay. So they used only one word. They used mirror formula. They didn't use mirror formula for a concave mirror when the object is placed at this location. So to generalize this formula, we are using sign convention in the process of derivation. And while solving the problems also, we'll be applying the sign convention, because we don't know under what scenario this particular formula is derived. So it is important for us to apply the sign convention again in the problems. I hope you are able to understand this point. Right. So as a part of homework, it will only take 5 minutes. You guys can take F and P as a scenario, that is object placed between the focus and the pole, and try to derive the formula. Okay. We'll do one last concept that is there is magnification, or we call it as linear magnification. So linear magnification is represented by the symbol M. So what is going to be the formula? What is going to be the definition of it? Any idea? So what is the definition of linear magnification? It is defined as the ratio of what? It is defined as the ratio of
Object distance and
no. Size of the image to the size of the object. So magnification will be equal to size of image by the size of object. So what is the size of image? It is Hi divided by H. Okay. So if you see the derivation itself, you would have derived this here. We got H0 divided by Hi is equal to minus U by minus V. So they'll get cancelled. See, this is a derivation which can be taken from anywhere. H0 divided by minus Hi is equal to minus U by minus V. You take any of the 8 scenarios, you will get this step for sure. Which implies Hi divided by H0 will be equal to V divided by U with the minus sign. So if I push this minus sign to the other side, Hi divided by H0 is equal to minus V by U. But what is Hi divided by H0 called as? Is this not called as the magnification? So the magnification formula for a mirror is minus V divided by U. Okay. So this is all about the mirror formula and its magnification. Let's do one simple problem and then we can wind up this session. So there is an object placed at 10 centimeter and 5 centimeter in front of a concave mirror of the radius of curvature 15 centimeter. So if I take the first scenario, u is equal to 10 centimeter, radius of curvature is 15 centimeter. Find the position, nature, and magnification of the image in this case. So u by default is negative. So radius of curvature for a concave mirror is also
Negative.
okay. So 1 by v plus 1 by u is equal to 1 by f, or I can write it as 2 divided by r also. So 1 divided by, whichever is unknown, don't apply sign convention to it. 1 by v plus 1 by u is minus 1 by 10 is equal to 2 divided by minus r is minus 50. So 1 by v is equal to 1 by 10 plus 2 by 15. How much will you get the answer as? 15 plus 20 divided by 150, that is 35 divided by 150 is 1 by v. So v will be equal to 150 divided by 35. So these many centimeter, and you are getting a positive value. So positive value means actually you are supposed to get.
You get a negative value.
No,
Sir.
the 2 by 15 won't become positive, sir.
I changed it here. So you will get 15 minus 20 divided by 150. That is minus 5 divided by 150. So you should actually get minus 30. See here, the point I wanted you to make a notice. If you take this as the concave mirror, the concave mirror's radius of curvature is how much? 15, correct? Where is the object? So radius of curvature is 15 means focal length will be 7.5. Right? Now where is the object placed? Object is placed at 10. 10 is between C and F. So when it is between C and F, where will the image be formed?
At C, sir.
Between C and F, where will they be? According to the ray diagram's concept, it should be formed beyond C.
Beyond C.
So beyond C means your answer should be a value greater than 15 centimeter. Are you getting it? And it should be a real image. That is why you are getting a minus sign. So with respect to a mirror, what do you mean by real image? With respect to a mirror, the real image means the image, object, and so the image and the object are of the same side. If they are on the opposite side, it will be called as the virtual image. So when you take 5 centimeter, so 5 centimeter means you think logically, right? Where is the object placed?
Between F and P.
Between F and P. So when you place the object between F and P, where will the image be formed? If you don't remember also, it's fine. So when you place it between the focal length and the pole, the image will be formed beyond the mirror and give you a virtual image. That is the only case where a concave mirror will give you a virtual image. So answer should be positive. So I will do and show it here itself. So here it will become here it will change to 5. So 1 by 5 minus 2 by 15. So 15 minus 10 divided by 75. So 5 divided by 75, V will be equal to 15 centimeters. So we are getting a positive value, right? So positive value itself says that it is formed beyond the mirror. So it is a virtual image. Are you able to understand? Similarly, when you're doing the magnification, right? Magnification is equal to minus V by U. Minus V by U is the formula. Minus of, in the first case, V is minus 30, U is minus 10. So what will you get the answer as? Minus 3. So magnification is negative means inverted image. Okay. So I repeat, V is negative means real image. M is negative means inverted image. Real images are always inverted. First point to be noted. Similarly, the magnification in second case will be minus V by U. So it is minus of 15 divided by minus 10 minus and minus 15. So you get that as V by 2, which is 1.5. So U is Second case U is 5 now. So we'll get plus 3. So plus 3 implies magnification positive implies it's a erect image. Okay, so what can you conclude from this? Virtual images are always erect. It's a known fact. Correct? You're able to understand, guys?
Yes.
Yes, sir.
So this is all about mirrors. All these facts you would have known. So with this mirror concept is over, that is the reflection part is over. Now we need to think of refraction. Okay.
I have a doubt, sir.
Please tell me.
When magnification is negative, what does it imply?
When magnification negative implies it's an inverted image.
It doesn't tell anything about the size, sir.
Value will tell you about the size. See, magnification negative has nothing to say about the size. It only because negative or positive is used only for sign convention. It will tell you whether it is the object or image is upward or downward. Correct? Whereas if magnification, see for example, is -3, magnitude of magnification is 3. So if the value of magnification, magnitude of magnification, if it is greater than 1, it is a, you tell me, is it an enlarged image or a diminished image? Magnification is greater than 1. See, suppose you have a water bottle in front of you and you're trying to look at enlarged. So this will speak, the number will speak about enlarged or diminished.
So, sir, in this question, they ask the nature of the image, sir. So we should put the height
Nature
as
is
well.
real and inverted, that's it. Nature is real and inverted.
Okay, sir.
That is the nature. You work on it. If there is any other doubt, you can ask me in the next class. Tomorrow we'll be starting refraction. Okay. So I'll see you guys tomorrow.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you.